So coming to the last session of this unit 2, that is design of fasteners, where we have just gone through the problems on riveted joints subjected to various stresses like tensile, shear and compression. This unit is there in our syllabus of our 5th sem automobile engineering by name design of machine elements. By the help of the LMS system and by the unit of LMS and with the Department of Collegiate and Technical Education, Government of Karnataka, the second unit will be completed. After the completion of the second unit, we will go for the third unit in the next session. So first we go to solve the remaining problems in this session so that we can complete the unit number 2 for the student, to help the students so that they can utilize and they can go through it, understand thoroughly, so that by the time of this pandemic, the students are suffering a lot. So it is a very good suggestion given by the department as well as by the government of Karnataka. Table of the content, we have simple problems on butt joint and then we have MCQs. So a double riveted double cover butt joint. Here we come across directly with the double cover butt joint. 12 mm thick and plate 18 mm diameter. Find the efficiency of the joint for a pitch 80 mm. If sigma t is equal to 115 megapascal and tau 80 megapascal and compressive or crushing stress 160 megapascal. Write down the data first, that is t is equal to 12 mm, d is equal to 18 mm, d is equal to 18 mm, p is equal to 80 mm, and n number of rivets 2 and double with the double shear. We just come across sigma t, that is 115 megapascal, which is clearly mentioned, the conversion 115 Newton per mm square, and shear stress 80 megapascal, 80 Newton per mm square. Then we have compressive stress 160 megapascal, that is equal to 160 Newton per mm square. He is asked to calculate efficiency of the joint, that is given by ratio of the least of the 3 strength to the unriveted strength. Now first of all we calculate the PT, that is the strength to be calculated. Therefore first we begin with PT. PT is given by P minus dt sigma t, that is there in our data handbook 5.11, equation number 5.11. With the help of that we just get the equation, and by the equation, with the help of the equation and with the help of the data available in the problem, substituting the two, we will have the value of the strength is 85,560 Newton. Then we go for finding the shear strength, that is given by PS is equal to N1 plus 1.875 into pi d square by 4 into tau, and it is there in our data handbook 5.13. That will be converted into 2n pi d square by 4 into tau, because 1.875 is recommended for the boilers. So now we are not considering the boiler. The same equation is there in the data handbook, no other equations are there for PS, so we have to mention the equation and just we have to round off it. 1.875 should be in the decimal form, should be rounded off to 2 or further calculation. 2 into n into pi d square by 4 into tau, where n is nothing but 2 here. number of rivets row. Therefore PS is equal to 2 into 2 pi into 18 square by 4 into 180. The value will be 81,430.08 newtons. The last is crushing strength of the rivet, that is given by N1 T1 and N2 T is D sigma C, where the equation is 5.14 in the data handbook. Now you substitute the values of N1 and N2, we will get NT is D sigma C, where N1 is 0 because it is a lap joint and N2 is a butt joint. 2 into 12 into 18 into 160, that the value comes to 69,120 newtons. Out of these three values, the least, I think PC is the least because it is 69,120 newton. Just you mention it, the least value is PC, and you calculate the strength of unriveted joint, that is P is equal to P T sigma T. The value will be 1,10,400 newton. Now you divide both the values PC and P, list of the values PT, PS and PC. You just divide PC by P, will get 69,120 by 110,400. The value multiplied by 100 is 62.6%. The value will be 62.6%. So this is the answer what he was expecting. Okay. After completing the first problem, we go for the second problem. The second problem is same problem, that is double riveted double cover butt joint, but zigzag manner is given and it is not a chain type. The rivets are in a zigzag fashion, Z fashion. That is the meaning. And with the thickness is given, no other data are given. The thickness is 15 mm and other data like D and P are missing, that we have to calculate here. That is complete design of the riveted joints. Sigma T is given 100 megapascal, tau is given 80 megapascal, sigma C 160 megapascal. State how the joint will fail and find the efficiency of the joint. Okay, write down the data is given. Then the data is only one data is there, that is T is equal to 15 mm. N is equal to number of rivet and it is a double shear. Sigma T is equal to 100 megapascal, tau is equal to 80 megapascal, sigma C 160 megapascal. And we have to calculate what is the efficiency and failure of the joint. To find the diameter of the rivet, we have to use Unwin's formula because the thickness is greater than 8 mm. So by the help of the Unwin's formula, the value will be 6.07 T under root 2 6.325 under root T. And the equation 5.22 C 64, page 64. The value comes to be 23.5 to 24.5. We adopt 23.5, then round off it, we will have 24 from the table. So when you see the table, the standard table, the nominal diameter seems to be 24. Then we will have the hole diameter, that is the standard size of the riveted hole, D actually is given by 24 plus 1, 25 mm. The 25 value, whatever we have got now, that value should be considered for the calculation. Pitch is calculated. The same thing, whether you can go by the comparison of the tearing and shearing strength, and then calculating by the standard equation provided in the data handbook. Then comparing both, whichever the value least comes, you adopt that pitch. Or you go first calculating the equation adopted in the table to calculate the pitch. Then you compare both the equation, that is the tearing and the shearing. Then compare both the values, that is whichever is the least, you take it for further calculation. So we will begin with the tearing and shearing stresses. With the help of these stresses, and then we calculate the strength by the help of the equation 5.11 and 5.13. Then compare the strength to get the value of the pitch. Okay, it is given by P minus 1500, and similarly the shear strength is given by 2, means double shear is there, that's why it is 2. 2 into N is 2, therefore the value is 157. 1,57,079.63 Newton. Equation 2 and 1, compare both the equations. PT and PS is equal to B minus 25 1500 is equal to 157079.63. The value will be P minus 25 is equal to 104.7, approximately 105. Now P is equal to 105 plus 25, it is 130 mm. And when you go by the equation, that is the maximum pitch is given by the equation, P max is equal to K1T plus 41 mm. By the help of the design data handbook to 5.23a, K1 is taken to be 3.5 from the table 5.4a for double riveted double cover butt joint. The K1 constant is taken by the table 5.4 and its value will be 3.5. So now substitute the values of K1 and T in the equation 5.23 to get the result 93.5 mm. So when you see the two values, the comparison value between the strength was 130, whereas the maximum pitch by the equation it is 93. Out of these two, the least should be considered, and the least will be 93.5. Make it a round figure to 94 mm. So then you calculate the other data in the same way what we have done in the last session also. That is, we have done already this part in our 10th session. Distance between the two rows of the rivets is calculated. That is given by PT or PB, transverse pitch or back pitch. That is given by the equation 5.31b, 0.33p plus 0.67d. When you put the values of pitch 94, that is adopted one, and 25, the diameter will have the value 48 mm, transverse pitch and or back pitch. Then you calculate margin M is 1.5d, 1.5 into 25, that will have 37.5 mm, and we take it as 38 mm. Then he has asked to calculate the efficiency of the joint, so we have to calculate the strength of all the three stresses, like tearing strength, P minus dt sigma t. The value will comes to be 1,03,500 Newton, that is PT, and PS is already we have calculated in the previous part, that is 1,57,079.63. Similarly, we have PC, NT is D sigma C 2 into 15 into 25, 160, 1,20,000. Out of these three values, the least value seems to be 1,03,500, that is the PT. It is the least value. Therefore, the joint will fail under tearing. You have to write it. Hence, the joint will fail under tearing of the plates. After calculating this, we come across efficiency of the joint. Efficiency of the joint is given by least value of the three and divided by the strength of the unriveted joint. And the strength of the unriveted joint is given by P is equal to PT sigma T, that is 1,41,000 Newton. So now when you divide all the values, 1,03,500 divided by 1,41,000, we will have 0.73 4 into 100. So to get the percentage, we have to multiply 100. Therefore, the efficiency is given by 73.4%. After this, we will have some MCQs. This is calculate the diameter of the riveted by the tensile consideration. If the permissible tensile stress in the rivet is 120, thickness of the plate is 12, pitch is 60, and load is 50 kilonewton, you just go through the answers. The 4 answers are there. You just calculate it, because he has asked to calculate the diameter under tensile consideration. Pitch is given, thickness is given, and load is given. That load will be equal to P minus D into T into sigma T. We will get out of these 4 correct answer. Okay, we just go through it. It is a homework for you people. Then we have find the efficiency of the riveted joint if it fails under tensile. If pitch is 70 and thickness is 60 and the diameter is 24, we will have P minus D by D. P minus D by P. Sorry, P minus D by P is the answer. P minus D by P, just go through it, because tearing strength or tensile strength is asked, and the least is basically that itself. Therefore, he has mentioned. What is the tearing equation? P minus D into T into sigma T. And what is efficiency says? The least of the value divided by the unriveted joint, and unriveted equation is Pt sigma T. When you divide P minus dt sigma T by Pt sigma T, T sigma T cancels, giving behind P minus D by P into 100. P is 70 and D is 24. You just go through it, divided by 70, you will have the answer here. Calculate the diameter of the riveted by shear consideration if the permissible shear stress is given and load is given. Butt joint, single cover, single rivet, double cover. Butt joint, single rivet. N is 1, but the shear is there. N is 1, but shear is there. Okay, means 2 is there, but in the shearing equation 2 is there, but not the number of rivets. Okay, N is 1. You just go through it and calculate and get the answer. Okay, this is a homework for you peoples, and a few more problems are similar to the what we have given in the session 9, 10 and 11, the final session. So you just go through it, practice it. Totally it becomes 8 problems for you, and you can be thorough in almost all type of problems, because our main motive is to thorough you people, so that you can get out of this subject. Okay, clear? Right. So the reference books what we have used here is R.S. Kurmi, a textbook of machine design by R.S. Kurmi and J.K. Gupta, and we can use a few more books are there, we can use it, but we just gone through this. And one more book is there by name J.B.K. Das and P.L. Srinivas Murthy, Dr. P.L. Srinivas Murthy, volume 1 and 2 of our machine design. And the data handbook what we have referred is K. Mahadevan and K. Balavira Reddy. Okay. Then coming, thanks for this session, that is the unit 2. After completion of the unit 2, we just thanks. So it is our chairman Gopinath sir, Gopinath K. He is from SJ Polytechnic Bangalore, and our sir Jagadish Bagli, he is from GPT Bagipalli and is LMS coordinator. Then we have moderator Takappa Chavan, Mangalore Polytechnic, that is Karnataka Government Polytechnic, Mangalore. And 3 subject experts, Kuruba Siddhalingappa of GPT Ballari, Shamboji, S.S. Shamboji of KHK Institute of Engineering, Dharwad, Gururaj Deshpande, Government Polytechnic, Belagavi. These 3 persons are the subject experts, and the remaining are content developers. That is Sharanappa Purat from Gomtesh Polytechnic, Muhammad Faiz Ahmad, HMS Polytechnic, Tumkur, Sharanappa Y. Purat, Gomtesh Polytechnic, Belagavi, Muhammad Faiz Ahmad, HMS Polytechnic, Tumkur, Bhimsen, Koralahalli, Rural Polytechnic, Hamsbavi, Dinakar P, SNS Polytechnic, Mangalore, Vinayaka S. Nayak, TSIT Polytechnic, Hubballi, Suresh DB, SNM Polytechnic, Mudbidri. Thus thanking one and all, have a